The Addams family. Dun-dun-dun-dun, dun-dun-dun-dun. I got terrible rhythm. CPU board and driver board. The driver board had the biggest issue, and the problem was that it was blowing fuse F113, the third one down, which is a 5 amp slow blow. And the root cause for that was a failed bridge 2. So I have replaced bridge 2. I replaced C5. I always do that while the board is in here. C11 was damaged, so I replaced it also. I took the heatsink off and I realigned whatever this is, BR1, I guess, and put new heatsink compound on there. Somebody had replaced BR2 in the past, but they didn't put new heatsink compound on there, which is an important thing to do. So I've replaced the fuse, those caps, replaced C4 here and C2. While I'm at it, somebody asked in a comment the other day is why I use a radial cap here to replace what was originally an axial cap, which would have tied down right over here. And the reason for that is axial caps have gone obsolete, and we are no longer going to be able to get them sometime in the near future. That is because they take up too much board real estate, and everybody is using radial caps these days. So whenever I have the opportunity to use a radial cap instead of an axial cap, and it still works right, and of course looks good there, I do that just so I can preserve the axial caps that I have. I also put a 1N4004 diode banded side down attached to R224, the big sand resistor, and that prevents a current backflow issue which can damage C11. And the GI headers on this board were really nice, so I didn't bother with those. Power out, power in header, and the 12 volt unregulated header I've replaced. So I've placed the game on free play. Let's get back out of here and back into tests. And we're going to test the whole board set. The MPU, I just installed NVRAM and replaced the 5 volt filter cap and J210, the power input. Sorry for that big fat hand there. So let's go through diagonally these switches, and this will prove that all the rows and columns are working. I've also installed something new on my bench, Victor's test rig or test board, which this is one. This came from Victor, and this came from Victor also, and these replace more crudely built boards than I had in the past. Victor has done an outstanding job on these. But what we can do here is test the end of stroke switches, even on an Addams family. This will work. And this is really testing the Fliptronics board and communication with the MPU board. So I'm not going to press the flipper switches because, why not? Probably work. Oh, I don't have power connected to them. But the, oh, there we go. Sorry, that was the lower right flipper, which I may not have connected. So 1, 2, oh, I got a blown fuse in there. But that's good to know that those flipper circuits are working. And the high voltage is a 72 for the coils and 21 for the flash lamps is correct. We've got 11.9 on the 12 volt regulated, 15.1 on the unregulated, and 492 on the 5 volts. Let's back out of here and test the rest of the things that we need to test. Solenoid test. We'll get it to cycle. Been cold here in St. Louis lately. It was 5, I think, the other day, because I was talking to a buddy of mine about how heat pumps only work down to 5 degrees sometimes. So you can see all those working properly. Let's do the flash lamp test. And they run in a different order on my test rig because this is set up for the WPC test ROM, but those are all working correctly. GI, you can see that's going to be working correctly already. And all 5 strings are dimming like they should. If you're ever tempted to change a, people call them transistors, but they're really triacs. They're attached to these big old heat sinks. If you're ever tempted to change one of those out, just don't. They never fail. Here's the lamp test. All rows and columns the same brightness and working properly. And that's it. I want to say, yeah, this board pair is good to go. I thank you so much for sending it.